Today we're talking about bisectors and triangles. So in this section and the next section, 4.4, we're going to have a lot of vocabulary that is probably going to be brand new to you. So it's important that you kind of follow along and make notes when you see these different words so you understand what they mean. So I made a little list here, right here in purple, of the new words or phrases that you're going to see in today's section. So concurrent, point of concurrency, circumscribe, circumcenter, incenter. I assume that most of you probably don't know what any of these things mean, so hopefully it'll make more sense when we're done with this section. So let's get into the notes. When three or more lines intersect at one point, they are called concurrent. So there's our first word from the list. So concurrent just means when three or more lines intersect at one point, which is going to happen, as you can see in this first shape that we have. So the point that they intersect at is called, well, you could probably guess by looking at the list, but that point is called the point of concurrency. So we got a theorem, concurrency of perpendicular bisectors. So perpendicular bisectors, something we talked about yesterday. The perpendicular bisectors of a triangle intersect at a point that is equidistant. So what do you think the word equidistant means? I should have put that in the list too. So first part of that, equal, distant means distance. So equidistant just means equal distance or the same distance from the vertices. So the vertices of a triangle are the corners of the triangle. So like A, C, and H, or B. I can't tell what the letter is. I think it's a B. Those are the vertices of the triangle. So what this thing is saying, it's actually talking about the circumcenter. So point P right here is the circumcenter of the triangle. So the circumcenter is when we have a circle that is circumscribed around a triangle. So the circle will touch all three of the vertices, all three of the corners of the triangle. B is the center of that triangle or that circle. It is also where the perpendicular bisectors meet. So this is a perpendicular bisector. This is a perpendicular bisector, and then this is a perpendicular bisector. That was not good. So again, perpendicular means that when two lines cross each other, they form a 90-degree angle. Bisect means to cut right down the middle. So this bisect man's cutting right down the middle at a perpendicular angle. And then they also tell us that the circumcenter is equidistant from each of the vertices. So here's a line from this vertex, here's a line from vertex A, here's a line from vertex C. So it's saying that all three of these are the same length. Since this is a bisector, these blue lines are bisectors, I know that it's right in the middle. This is the midpoint of AB. So these two segments have to be congruent. This again is a midpoint, so this segment and this segment have to be congruent. And then this segment and this segment have to also be congruent. So that's the circumcenter of a circle. So that's when we have a circle circumscribed around a triangle, touching all three of its vertices. So number one, example one, what congruent statements can you write for the inscribed triangle below? Well, this is a circumscribed circle around the triangle. Point P is the circumcenter. So if we took our little perpendicular bisectors, that's where point P would meet.